So here, no? And then therefore, to the right of that, that would mean an integer scale of n equal to 1, n equal to 2, and so on and so forth. To the left of the 0 would mean an integer scale of -1, -2, -3. Okay? So parang ganon. So I given it that note, so you'd end up with this graphical depiction of how that impulse signal is. And if we try to subject that to your impulse, doing your, let's say, convolution theorem. This is basically the concept of the convolution theorem. And we're going to use the direct method, meaning we don't have any idea how to perform, literally, no? You don't have any idea how to perform convolution theorem. You could actually do something crude like this. So at y equal to -1, we know that there are no signals, okay, according to the impulse responses, no? Okay, there are no signals at the left of your uh, values, no? Yung ating impulse, I'm sorry, yung ating unit step. Therefore, we already know if y is -1, the value there is 0. Okay, if our output y at -2, it's still 0. Our output y at -3, it's still 0, and so on and so forth. Okay, so if we start off with y at 0, because we have a value at 0 which is equal to 1 given off by our unit step here at the shan. And all you have to do is to substitute those values of x at 0, because we're dealing with x at 0 at this position. Okay, on this input-output relation to determine y at 0. So that is, if I wanted to evaluate the output y at 0, I will replace all these values of n with 0. And then what? Determine the signal at this given values of x. And then what? Apply them and substitute them onto this linear time invariant system. Okay? And as you see, this now would result in to be at x0 minus twice. So if n is 0 there, this would be, oh, sorry, that should be x first. sorry. Tanga lang. Okay. X at, lalabas kung 0 yun, -1, di ba? Plus 3 times at x 0 minus 2, -2. Di ba? But remember, at these integer values of n, your amplitude or response is simply 0. Therefore, this becomes 0. This simply becomes 0 kasi 0 daw yun. Multiplied by 3, 0 pa rin. 0 multiplied by 2, 0 pa rin. Nakuha ba? But at x at 0, we know the value to be 1. Ito siya, no? On our graph. Tama ba? Nasundan? Since there are no pre-existing values for your x at the left of your given unit step. Okay? So therefore, the only solution there would be yung x at 0 mo. Basically like that, no? Okay? Which is obviously equal to 1. Okay? Next. If n this time is 1, so again, just substitute the value of n here. That would mean x at 1. This would be x at 1 minus 1. This would be x at 0. Lalabas, no? This would be x 1 minus, so this would be x at -2. But we know, at -1, and we know that the value of x at -1 is simply equal to 0. Therefore, you'd end up with the value of 0 here when we substitute here. X equal to 1, yes. X equal to 0 pala to. Ito pala x equal to 1. X equal to 0, which is basically equal to 1. So, 1 yung value nyo. Tapos, x equal to +1, because n there is 1, and the amplitude there is simply 1 then. So we substitute it here, and we end up with an answer of -1 for your y at 1. Okay, follow so far? So ganun, no? So basically, ganyan lang yung crude na step. We will we'll analyze that one at a time, solving for different integer values, no? So at y equal to 2 naman. So what would be the response? At y equal to 2, therefore this n value now becomes 2. This is 2. If this is 2 now, what is x at 2? It's simply 1. What is x at 2 minus 1, which is 1? X at 1. What is 2 minus 2? This would be x at 0. Therefore, the value of x at 0 is this. So, and all their amplitude is simply 1. So if I replace that on my given LTI system, these are my signals. So I'd end up with a value equal to +2. Okay? And we'll continue on with the process for n equal to 3. Okay, at n equal to 3, what would be our output y? At n equal to 3, of course, this would be 3, x at 3, but this value becomes 0. Wala namang x at 3, no? Kasi 0 yung amplitude natin at x at 3. So 3 minus 1, this would be x at 2, and we know that at x at 2, the value is 1. So hence, the value is 1 there. And then x at 3 minus 2 would be x at 1. Tama. X at 1 here. And the amplitude value there is simply 1. Ito na. So if I evaluate now, the answer would be +1. And at y at 4, I'd end up now with, so if y at 4, this would be x at 4, but my x value at 4 is simply equal to 0. Therefore, this would be regarded as 0. And this is 4 minus 1, which is your x at 3, but your x value at 3 is simply 0. Therefore, it's simply 0 here. Substituted 0 here. And then here, it's 4 minus 2. Therefore, this would be the x value at 2, which is basically 1 based from our unit step signal. Therefore, this is 1. So you'd end up more or less with this corresponding value. And notice that if you continue on evaluating for y at 5, y at 6, y at 7, they would all be zeros because the values of x there would no longer be existing. There are no values of x there on those given values of x if you consider your n to be equal to 5. So basically, this ends our given output. No? So if you do look at it, no, starting from y at 0 hanggang y at 4, yung ating output that we managed to evaluate. Okay? So that's basically how direct method works. Okay? Very crude. However, in some cases, if the linear time system tends to be a bit complicated in analysis, this would be a bit complicated to do, no? Parang ganyan. So, which is why there are other alternatives to do that convolution technique, no? So hence, if I write down the final output response, this would be the resulting array if I discretely write down the values for n equal to 0. Ito yung ano natin, in-underline lang ko lang. Okay? This would be the value at n equal to 0. This would be the value of n equal to 1. This would be the value at n equal to 2. This would be the value of the response at n equal to 3, and so on and so forth. Okay? So that now is what you call convolution process. Okay? So this would be your resulting graphical output for these responses. Okay? So one concept by the use of the convolution sum is through this process. Okay? So this particular process basically shows us first how to evaluate our impulse response. So how would we evaluate your impulse response? H. Ito yung impulse response natin. We know that this is your signal, which is typically this value. Okay? Ayan yung value ng signal mo. That's x of k. So we want to evaluate that, this is the LTI, this is your LTI, okay? And we want to get that uh, impulse response for your LTI, okay? So to get that impulse response for your LTI, I will assign your delta n to be equivalent to a value of 1 impulse. No? So if n is 1, what would be the value of your h? Okay, so subject that here on your LTI system, n is 1. So you'd end up with h at 0, which is equivalent to 1. H at 1, which is equivalent to basically negative 2. And if h is 2, this would eventually end up with negative 3. Kasi bakit? These are impulses, no? Introduced there. Okay? Impulses. Kasi if you look at the value for uh, h equal to 0, and this is a delta response, that would mean, di ba sabi ko, you could break down your signal into impulses. Okay? So parang ganito lang yan, no? I have this original signal for your impulse, which is the step size, no? Ito yung ating ito yung 0, ito yung 1, ito yung 2. This is our unit step. And I could easily break this down into like a delta function at 0, which is, ano yung delta function? It's 1 at this value and 0 everywhere else. Okay, 0 na siya. Yan. And then I add it with the delta impulse at 1. Okay? So ano yung delta impulse at, mas maganda siguro ilayo ko yung drawing para mas nakikita nyo yung output. No? Layo ko lang to. Okay, so it's like saying that this particular is like your delta at 0, and then I add it with the delta at 1, and then I add it with the delta at 2. And what is this delta? It means impulse, no? Impulse lang daw siya. So ano yung impulse? It's an amplitude of 1 at n equal to 0. So ito naman daw, impulse, kasi 0 everywhere else yan. Ano? So ibig sabihin the other values here are 0. Ito naman daw, impulse at 1. So pagdating sa n equal to 1, meron kang impulse dito. Then 0 everywhere else. Nakuha ba? So this signal, which is 1 here, this signal plus 1 here, 0 everywhere else, no? 0 anywhere else to, plus this signal here. Paano naman siya? Impulse uli siya at n equal to 2. So 1, 2, at n equal to 2, there's an impulse here with an amplitude of 1 and 0 everywhere else. Nakita ba? So if I add all these three signals, okay, it forms this signal, di ba? Nakuha yan? So, anong gagawin ko? I multiply this individual signal to your LTI. And notice if I multiply this signal at 0, dahil 0 siya anywhere else, this term, the second term, becomes 0. This third term becomes 0. Magkakaroon lang ng value ito, which should turn out to be equal to 1, di ba? Nasundan? Okay, pag ito naman daw, I multiply this value to your response. Ito naman daw ang multiply ko. Galing ko lang to. Okay? I multiply that signal to your response now. Ito. So, ano mangyari? S0 siya, walang value at x equal to 0. So, therefore, this term becomes 0. There's a value at x equal to 1. Di ba? Masundan? So, this term will have a value. Okay? Tapos, this term will be 0, which eventually should give you 2 times 1, which eventually should give you negative 1. No? Parang ganyan. And then finally, if I multiply this signal with an amplitude of 1, again to your LTI, okay, you will again notice that this time around, this term would be 0, this term would be 0, and only this term will be present. Okay, and that's it has an amplitude of 1, so if you multiply that with 1, so you would eventually end up with positive 3. So, ayan, no? So if I evaluate then the impulse response, Hn, that would mean 1, negative 2, and 3, which is technically, this one is at n equal to 0. Nakuha ba yan? Or basically, ganito lang siya, no? Since one of the simplest way to evaluate the impulse response of any given particular LTI system is technically taking their coefficients. Take mo lang yung coefficients nila. Tingnan mo yung coefficients. O di ba ito rin yun? Those coefficients are also this value. Di ba? Itong coefficient na ito rin yun. Itong coefficient na yun, ito rin yun. Di ba? You just take their coefficients. That's the simplest way or simplest approach. Because why? You're subjecting them to a delta, which is an impulse with an amplitude of 1. Therefore, kahit anong i-multiply ko dyan, pagka minultiply ko na 1, it's exactly the same value as my coefficient on my LTI system. Di ba? As simple as that. No? Yun lang yun. Basically, okay? Pinahirapan pa ni Sir. Ano? Pero ganun yun. Technically, that's how you evaluate for the impulse response. No? That's what I'm saying. Okay? But the easiest way, of course, is to simply take all of these coefficients of your LTI system. That's the simplest way to do it. No? Ganun lang siya. So after taking the impulse response, we know that they plotted like this. And ngayon yung plot nung, oh, this is supposed to be h of n. So nagkamali ako ng label dito. This is h of n. Ito na siya, yun. H of n. Okay? So that's supposed to be h of n. I then apply this convolution process on your signal. So we know that the response, the impulse response, when interpreted onto your formula, pag in-interpret natin sa formula, okay, starting with n at 0 here, this would be h of n. So pag in-expand ko lang to, no, basically, of course, from 0 to infinity lang ito, no? Okay, kasi bakit? Anything to the left of my impulse response, of my unit step is 0. Therefore, cutting my summation, hindi ko na dadaanan yung negative infinity, no? Nakuha ba? Kasi if you look at my unit step, which is all ones, di ba? It starts from n equal to 0. And then n equal to 1, and then n equal to 2. Therefore, I only have values at those given integer values. So beyond that, on the left side, puro 0 na siya. Therefore, in effect, I don't need to consider any summation there. Dahil puro 0 yan. If this value becomes 0, I multiply that with any response, then the response is simply 0, di ba? Ganun lang. So definitely, you don't need to get that output, no? Kapag ka n equal to negative infinity. You just start at n equal to 0. Okay? Tapos, if I shift that signal, okay, if I shift that signal on the right, it's now etong signal na to. If I shift that signal another one step to the right, it's now this signal. Nakuha ba? Okay, basically ganun lang. No? Pinaliwanag ko lang yung form ng formula. Okay? So, remember that this is the input signal, and that input signal basically is 0 on values that are negative integers and 0 above 2. So yung value ng 2. Okay? So remember our corresponding impulse response is this. Okay? And then what? We then shift this impulse response one signal to the right. So this is the impulse response at what? At 0. Okay? This is the impulse response at one shift. And this is the impulse response at two shifts. Okay? So, remember, I'm just like technically shifting the signal. No? Kasi time invariant siya, remember? So, if it's time invariant, the value will not change even if you shift the values. Nakita ba? Okay. So, now that I have this particular shifted values for my impulse responses, I then apply that particular technique called the convolution sum. Okay? So, under the convolution sum, it's mentioned there that all you have to do is to multiply all the terms that your signal overlaps at that given period and then sum them up. And the best method to do that is to typically just add the shifted signals. So, this is my LTI response at impulse response at 0. This is my LTI response shifted. Remember, ito na yung 0 ko, na-shift na siya. I just set it on a discrete level. No? Then, I shift it again, di ba? Si-shift ko siya uli. Ayan na. Okay? Kasi hanggang ano lang, second shift lang. Hanggang dalawang shift lang. Ito. Okay? Nakuha ba? Which is actually dictated by this value. Kaya hanggang dalawang shift lang. So, ayan na. After getting all those shifts, you simply add up all the terms that are aligned. Add mo lang to, add mo to, add mo to, add mo yan, and then add mo dito. That would be the output response now. That's how you typically apply convolution sum. So that's another technique on how to do the convolution sum. Nako ba? Get the impulse response, which is basically the coefficients of your given LTI system. No? Nako ba? And then of course what? Multiply that to your signal. So notice that the signal, since it's a unit step, tama ba? Since the signal is a unit step, you'd end up with the same coefficients. Nangyayari, ito lang yung coefficients natin. And we'll shift that all the way to 2. So shift natin yung signal twice. Okay? So one shift, then this one, shift again. And if you add all those terms, ayun na, this is the output. Oh, isn't this the same output that we got while doing the direct method? Naalala nyo ba? Ayun din yun, di ba? Parehas lang. Exactly the same. Okay? Nasundan? So that's an easier way to do the approach rather than technically solving it, no? Nakuha ba? But there is another method which is, I believe, the easiest one, okay? That is often applied to any particular discrete signal, no? Okay. Which is yung graphical method, okay? So I've given you the procedures for the graphical method last time, but I failed to show you how it's technically done. So paano ginagawa yung graphical method? So let's say I have my given LTI system and I have my given input signal here, which is a unit step. And then I get the impulse response, which is obviously this, and we know how to do that already. Tama ba? And then what do? We either flip the impulse response or flip your signal. Okay? So here, I just flip my impulse response. So when you flip your impulse response, so it becomes what? A mirror image, no? On the left. Okay? So note that the value at y at 0, the response at y at 0 remains the same. Ito pa rin yun. However, this one becomes the value at -1 and this one becomes the value at -2. Okay? Nakuha ba? Although technically, you could also flip this. Pwede rin. Ito. Okay? Either this impulse response or this given input signal can be flipped. No? Sabi. So here, I just flip the impulse response. And then after that, I shift the signal one step to the left. Okay? So shifting the signal one step to the left, what then would be our given output? Okay? So, start muna tayo. Kasi dito, notice here, at n equal to 0, nag-overlap na yung signal natin tsaka yung ating impulse response. Okay? So, I multiply those values, 1 times 1. This would be the value at n equal to 0. Tapos, dito ang amplitude ko, 0. My amplitude here is this value. Actually, kahit anong value, multiplied by 0, it's simply 0. Then here, my amplitude is this value. But since the amplitude here is 0, therefore it's 0. So ang gagawin ko dyan, whatever product I have this, I add this product here. I add the product here. So hence, we only end up with the value of 1. Nakuha? If you begin shifting now the signal, so i-shift natin ngayon yung signal, this is still the original input signal. No? So this time, I shifted the impulse response. Ito na ngayon, shift ko na yung impulse response. And note all overlapping values are eventually multiplied and then summed up. And that would be the value or output at y equal to 1. Okay? So notice here, nag-overlap yung ating signal na 1 and 1. If I multiply 1 with 1, it's simply 1. Nag-overlap yung ating 1 and -2. So 1 times -2 plus 1 times 1 plus 2 times 0 kasi walang value tayo dyan, no? Okay? Okay, so typically that's how you okay, so again, this would be the final value here for y at 1. Ito na, no? Okay? Which is technically, if you look at it, no, lumalabas ka sa akin, -2 times 1 is -2. Plus 1 times 1 gives you -1 now at y equal to 1. Okay? And then again, on the next signal, I shift the impulse again, one step to the right, and then multiply all overlapping values of my graph. And then sum them up. So, lumalabas dito, I multiply 3. Okay, what happened? I multiply 1 with 3 because they overlap in integer value. I multiply 1 with negative 2, and then I'll multiply 1 with 1. Nakuha? And then sum them up. If I add up all of those values, I would end up now with the output for n equal to 2. Okay? Which would be equivalent to, at n equal to 2, ito na ngayon yung value nating n equal to 2, which gives us positive 2. Okay? So if I compile that so far, our output values that we have considered at y equal to 0, it's already 1. At y equal to 1, the value is simply dito, negative 1. Correct, no? Ito yun. Ito naman yun, no? Ito yun. And then if the value of n is now 3, whereby you shifted all the values, you would end up now with a summation of this value, which is technically 2. And then shift it again. Ayun eh. If I shift that, the overlapping values appear to be at n equal to 1 and at n equal to 2. Kasi yung n equal to 3, if I multiply that value, ito, 0, multiply ko sa kahit anong value dito, obviously that would still be 0, no? Pag minultiply. Okay, so ito na yung values natin from... We'll shift it again one more time because the values still do overlap. So kung napansin nyo, there is still overlapping values here if I shift it, which is itong 2 dito at itong value ng 2 dito. Nag-overlap pa rin siya. So again, simply obtain the product and then sum them up. So this would be an amplitude of 3 times 1, and then here this would be 0 times whatever value this may be, 0 times whatever value this may be. So you'd end up with a summation equal to, sorry, yan. And you would notice that it's exactly the same thing that we plotted a while ago. That is graphical method. Okay? So when you do graphical method, always remember that under graphical method, you need to fold one of the signal. It's either X or the impulse response. After folding the signal or impulse response, you then shift it one at a time. Okay? And the values that do overlap, okay, yung mga values na nag-overlap between your X and your impulse response would comprise of the value. Okay, ito yung pinakamadali na sinasabi ko sa inyo, which is a convolution using an array or called uh, the other textbook I saw calls it Wonzy method. No? Although on the lesson, it's actually called a convolution array. Okay. So how is this done? Okay. Remember, you have your LTI system. And I want to basically on my LTI system
gagamitan ko ng ano, no? I will apply convolution theorem here. Okay? So, and this is my input signal. This is my impulse response, no, when plotted. So all you have to do is to create a table like this. Okay? Your kasi interchangeable naman to. Basically, okay lang kahit magkapalit, no? Okay lang yung position. But I usually place my impulse response here and your signal here. So when the impulse uh, response are written, it starts at n equal to 0, which is h equal to 1, then negative 2, and then 3. You know? Okay. Tapos yung ating impulse responses are placed here. Kasi at n equal to 0 ito. So take note, I underline there the value at the position n equal to 0. Okay, so paano ngayon gagawin ko? You multiply each term here. So I multiply 1 with 1, I have 1. 1 with 1, I have 1. 1 with 1, I have 1. I multiply 2 with 1. So I end up with negative 2, sorry. Negative 2 with 1, negative 2 with 1, negative 2. I multiply 3 here. 3 with 1 is simply 3. 3 with, sorry, that's, tama. Positive 1 is 3. 3 is 1, 3, ayan. Okay. After getting now the products on each of these boxes that I eventually have, I will now add all values. Hindi ko mapantay. Wait lang. Gamitin ko line. Okay. Now that I've gotten the products, I will simply add all of these values. Okay. That value, and then this value here, and then this value here, this value here, and finally this value. Ayan. So adding 1, this gives you the output 1, and then I will add then ito lang yung results ko. These are my results. Baka malito kayo. Ito lang talaga yung product result ko, di ba? 1. Ano pa ito? 2 at ito. Ba? So 1. That's the first value. Ano pa? Negative 2 plus 1, it's negative 1. Then here, ito yung result. 3 plus negative 2 plus 1. Di ba? 3 plus negative 2 is positive 1. Plus 1, therefore, it's 2. Then here, 3 plus negative 2 is simply 1. And finally, this one, 3. This is now your output response. O di ba, ito rin yung nakuha natin. Using graphical method, same answer. This is the same answer we got from when we were shifting the values. Alala nyo? Yung impulse response natin, sinishift natin. Yan din yung nakuha natin. And it's the same thing we got when we were doing the graphical method. Nakita ba? And ang kinaganda ng convolution array or the Wonsi method, you could use the technique regardless of how many input signals you have. Kahit ilan yung input signal mo, kahit ilan pa yung impulse response mo, magagawa mo tong convolution array. It doesn't need to be square. Okay lang kahit hindi square siya. Nakuha ba? Kasi dito lumalabas, sir, tatlo yung elements mo nung you have 3 elements for the impulse response, 3 elements for the input signal. Pwede kahit hindi pantay. Okay? Actually, pwede kahit yung 0 hindi sa position na to. Even if the value of the position of zeros are not here on this marked values, no? Kahit saan yun. So, ang lalabas lang yan, this is 0, this is 0. Ito ngayon yung value ko at n equal to 0. Which is this. That's the value at n equal to 0. So, meaning to the right of that, n equal to 1, n equal to 2, n equal to 3, n equal to 4. Nakuha ba? Okay, ganun na lalabas dun, ano? So, as seen here on this output and here on this graphical output that we previously determined. Nakuha ba? 1Z. So, let's try it out, no? Let's say I have this given LTI with an input signal of, ito na yung input signal ko, -3, -2, +2, and 1. And take note, this position that I have underlined is where n equal to 0 is. Nandyan yung n equal to 0. Nakuha? Okay? Tapos, ito yung LTI system ko. Okay? I just try to make it as simple as possible. You could actually make a complicated LTI system. Okay? Ginawa ko lang puro ganito muna. So, this is -1 and called, no? Basically, that's the LTI system. This is linear. This is shift invariant. Okay? Yan. So, we note that at 0, ito yung value mo. And coefficient niyan, 1. At n equal to 1, itong value mo, ang coefficient niyan, 1. At n equal to -1, ito yung coefficient mo, ang value niyan, -1. Nakuha? So, we create the convolution array. Okay? So, pag ginawa natin ngayon yung convolution array, dito ko nilalagay yung impulse responses H. Ayos sumulat. Ayos sumulat. Okay. Andito yung impulse responses. So, lalagay ko rito -1, 1, tapos lalagyan ko ng underline, tapos 1. And dito sa taas, lalagay ko yung impulse, yung aking signal, no? Which is my x of n. So, lalagay ko lang dito, -3, -2, 2, i-underline ko yung 2 because this is where n equal to 0 is, and then 1. And then, multiply ko lang ulit like I did, no? So, -1 times -3, I'd have a product of 3. -1 times -2, I have a product of 2. -1 times 2, I'd have a product of -2. -1 times 1, so I'd end up with the product of -1. Then positive naman yung 1 ko susunod. So positive 1, so -3, -2, 2, and 1. Okay? Then positive 1 ulit. So -3 ulit, -2, and then 2, and then 1. Okay? So ano yung mga output ko? Ito. Ito. Ano pa? Ito. Ano pa? Ito. Asan pa? Ito. At ito. Nakuha yan? Okay. Where is my n equal to 0? Ito yung n equal to 0 ko. I have it here. Nandito yung n equal to 0 ko. Therefore, at this given product, nandito yung n equal to 0 mo. Anong value lalabas dyan? Okay? So meaning, ang first output natin ng y of n is simply equal to, after the response, no, is equal to 3. Next, -3 plus 2 is simply -1. Next, -3 plus -2 plus -2 gives us -7. Okay? Then, dito, -2 plus 2, 0. Minus 1, -1. Ito ngayon yung n equal to 0 mo. Nandyan. And then 2 plus 1, this is 3. And then finally the answer is 1. Ito ngayon yung output mo. 'Di ba mas madaling gawin? This approach is actually fastest, no? When it comes to answering your convolution process. Okay? Nakuha? Convolution. Oh, that's how you do it, no? Okay. So I'll end the discussion here on the convolution. So the topics under the first module exam will cover, of course, signals. You have there the different types of signals. You have the basic operations on signals, and all the way up to ano muna, convolution lang, no? Yan, yung process ng convolution. You could apply any approach there. Ayan, which is why I gave you all the different approach, no? That you could apply. But as I mentioned to you, this is the simplest way to do the process, and it's the fastest way to do the technique. Nakuha? Even if notice, no, kahit hindi square yung lumabas sa atin, because there are like 4 signals here, and I have 3 3 coefficients ng response dito, no, ng impulse response ko. Okay? Nakuha. So kahit hindi parehas yan or kahit madami pa yan, okay, madami yung elements included on my LTI system, marami yung discrete signals ko that I want to apply with convolution, you could easily evaluate that using Won-Z method. Nakuha ba? Okay, so that covers our discussion. By next meeting, Monday, we could have our module exam. So medyo na-delay yung module exam. Okay? Because I was trying to cover all the way up to convolution. Kasi ang coverage talaga niyan hanggang convolution. Because the next module covers, actually pwedeng mauna yung Fourier transform or Z transform. Anong gusto nyo? Pwede namang mauna yung Z or Fourier. Kahit alin doon, interchangeable naman siya. Kasi totally independent siya from the other. And there would be similarities regarding one technique over the other, no? Similarity ng Fourier do sa Z, similarity ng Z do sa Fourier. Nako ba? So typically we'll just continue on with Fourier. So Z transform na lang muna. Sige, Z na lang. Kasi yun yung nakalagay sa syllabus. Okay? So, and you will notice that this convolution theorem extends all the way to these different techniques. No? Kahit gumagamit pa ako ng Z transform, kahit gumagamit ako ng Fourier transform, gagamitan ko pa rin pala ng convolution theorem. Paano ko gagawin yun? Ganyan pa rin. Exactly the same. Yun yung kinaganda, no? That's the beauty of the convolution theorem. Because if you convert these signals into a different domain, convolution becomes easier. And that's how the process is, no? Which is why we want to analyze signals on a different domain other than time domain, no? Bukod sa time domain. Okay? Even if you have like complicated signals, although under discrete, puro stick lang naman siya, no? Hindi naman siya complicated siya, puro stick lang siya. But when you analyze the signals, it becomes a bit complicated, no? Even if you are on a time domain and even if you're doing discrete signals. So which is why they are usually converted into another domain. Nakuha? So again, let me remind you that we will be using Manicam during the exam. So kindly configure your system using Manicam. I've already uploaded there on your Blackboard how to do that. And if you haven't seen that, it's actually on your course material. So go over to your course material. You will see there how to use Manicam in Zoom. Okay? So meaning, you have to lay it out that I could see your entire screen, desktop screen, while doing while answering the exam with you on the background. So meron kang small square dyan, tas nandun yung camera mo in front. So your Manicam could do that. Nakuha ba? Okay. Nasundan nyo na. So you have to do that. And then that will be our requirement for the exam. If you don't have that, I believe other programs are also have that. So you could install that. Kaso nga lang, alam ko lang Manicam eh. However, on other devices, you could also use that. Kung merong feature yung ganun yung device mo, then okay lang, no? Let's say you could screen share on your device, then do that, no? Screen share para makita ko on the Zoom your screen. Ganun siya. Plus your dapat nakikita rin kita kung what you're doing. Okay? Your camera, your face. Nakuha ba? So kasi kaya yun nung Minicam. So I will end the discussion for now. So kindly turn on your cameras for a few seconds so you'll be recorded within our session. If you haven't gotten a camera, kasi si Mr. Miguel yun, meron ka bang camera? By next meeting, dapat meron kang working camera. Okay. By next meeting, dapat may working camera kayo. Okay. So thank you very much, guys, for joining in our session. Thank you. Stay safe. Stay healthy. Yes, you may log out of our session now. Thank you,
Thank you,
guys.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you. Stay
Thank you,
safe.
sir.
Thank you, sir.